Let's do it live.
We're doing live. We're doing it live. Our special guest today is Bill O'Reilly, also joined by Severin. No, for real, very, very nice to be here. I'm recovering from COVID. This is our live stream number 111. This goes up to 11 and to 111. I'm very excited for today's live stream. We have an awesome guest who's well experienced, given plenty of talks before, and said that I have full right to interrupt him whenever I want, not only when there's a question, but whenever I feel like it. Anyway, folks, just quick reminders. As you know, we've always got stuff going on in the Data on Kubernetes community. And the most recent piece of news is our KubeCon DoK co-located event, CFP. I'll leave the link here. There are very clear instructions. I'll say right now, no vendor pitches. I'll say it again, no vendor pitches. And just to be extra sure, no vendor pitches, no vendor pitches. Please, we want talks that are educational, talking about running stateful workloads on Kubernetes as often as possible, get end users into the picture. You have extra guidelines in the CFP. So don't just copy and paste the talk that you gave 2 years ago at some open source conference. Remember, we're looking for stuff that's focused on data on Kubernetes. That being said, pretty straightforward. I want to turn it over to our very accomplished guest. Severin Ryberg is no stranger to data pipelines. And today we're going to be hearing about Dask as well as Argo. We've heard a little bit about Argo before and its wonders. But today we're going to be hearing a little bit more. But before we get started, Severin, can you just introduce yourself? Tell us about yourself and tell us what your favorite food is now that I've lost my sense of taste and smell.
Oh, really putting me on the spot with the food there. Food.
You start with the technical introduction, then we can move over the food.
Sure, yeah. Great. Actually, I have a nice slide to answer this specific question.
Jump right in. Do that.
If you don't mind, I would
take
be happy
advantage.
to.
Yeah, do so.
All right, so let me throw up my screen. Please let me know if you see it.
I will. Oh, we can. And that is a very nice looking coffee cup, which I believe I may have seen some of your other YouTube videos. Has it made an appearance?
I just took this picture yesterday, so I would be shocked if you had seen this one before.
That was color associations. Excuse me, but it's a beautiful coffee cup. Anyway, I'll be quiet now.
Like I said, you're welcome to introduce or interrupt as you wish. Cool. So specifically on the question of who I am, where do I come from?
Can you make that full screen?
Absolutely.
Yeah.
Actually, I can also even. Yeah.
Nice. Perfect. Yeah.
Nice.
Good stuff.
Okay.
Yeah.
All right. So yeah, just some short details about me. For quite a long time, I was on an academic track, originally in the direction of physics and electrical engineering. Actually, both of these degrees were at Texas Tech University. In the US, obviously in Texas. And since then, actually, I got into the direction of renewable energy analysis, first at the National Renewable Energy Lab sometime in 2015. At the same time, I was also adjunct professor at Colorado School of Mines. In both of these places, basically doing C++ development, here a developer / intern, here a professor. So it was quite a weird time in my life to be both of those things at once. But nevertheless fun and, of course, very technical. After that, I wasn't so done torturing myself academically wise. So I thought, yeah, why not go to Germany and do a PhD, which brought me out to the RWTH Aachen, where I did PhD research in renewable energy integrations across Europe, also energy system analysis. And I was maintaining the infrastructure stack for the research group. Roughly a group of about 70 or so people. That transitioned into a postdoc position, of course, where I wasn't just maintaining the infrastructure, but actually architecting it because the research group was growing. But then I'm happy to say that since mid-2020, I have been the infrastructure architect at ACCURE Battery Intelligence, which brings us to today. So that's my roadmap. And
still waiting on that favorite food.
Ah, yeah, favorite food. Oof. Okay. I'm going to send a shout out to my girlfriend who makes the most amazing little Turkish pizzas, she calls them. Super tasty. Sucuk sausage with a little bit of Gouda cheese on top of some bread with some mint. I'm not sure what else she does. A little bit of
no, that sounds really good.
Sauce. Really tasty.
You had me at Gouda cheese and Turkish pizza. If you could, would it be possible to send a picture afterwards in Slack so we can share it? Because I think everyone wants to know about this now. That sounds really
Oh,
good.
wow. Okay. Well,
If you have one, anyway, that's for the future. But we'll get to that later. Anyway,
now
go for it.
you're putting both me and my girlfriend on the spot now. You're
I know,
on
no,
on a roll.
No, but you did yourself a disservice by describing
That's
it
true.
so well. That sounds really good. As someone who has no sense of taste and smell right now, because of COVID side effects. But anyway, continue.
That's the real tragedy. Okay, back on topic. So, quick shameless plug for my company. So, ACCURE is a battery intelligence company started in mid 2020. So we're still quite young. We're closing in on about 50 employees, and we're hiring. In case you're interested in, rather interested in batteries and data and all these different types of things. And basically what we want to do is monitor batteries, compute their health, make sure things are safe, optimizing, these types of topics. Very heuristic algorithms. We have to write a little bit of ML, that sort of a direction. Our USP is that basically not only coming from a background in this topic, we also are 100% software driven, right? So we want to be able to solve everything with data, and with without having to put any hardware in the battery. So our ultimate goal is to monitor every battery on the planet. And our other USP is we're born in the cloud. So everything we do is in AWS or some other Kubernetes cluster. You will not find a workstation sitting in one of our closets. We have laptops, and that's it. Some of us even work completely remotely. So quite a nice edgy place to be. And the primary tools that we use are Python, AWS, and of course Kubernetes. That's why we're here today. And more on those later on. So my particular role at ACCURE is actually, I was the sole infrastructure developer for quite a long time. The infrastructure team has grown now to a size of about 10. So I'm doing a little bit more managerial work now, but I've basically touched everything under the sun in terms of infrastructure at ACCURE in the last 2-ish years. So, that includes data engineering, traditional development, DevOps. We use GitLab CI, cloud engineering, as I mentioned, in AWS, as well as Kubernetes. So, making sure our computation pipelines are schedulable and scalable. And that is it for my introduction. Hopefully that hits all the points. Yes, I'll just continue on then. Okay, so the talk that we're going to go into today is scheduled scaling with Dask and Argo Workflows. And the goals for this presentation are to understand why Argo plus Dask was a good choice for us specifically. I then want to provide like a rough overview of the infrastructure setup that we've used, and to kind of give you all some perspective there. But then I want to delve a little bit more into depth with a very basic example with Argo Workflows and Dask, going over those things that I've set up for you today. And then, of course, doing it live. So showing you how it goes. So those are the goals. And these are the different sections that we'll cover. All right, introduction. You already know who I am, so I can just continue past this one. And let's get directly into the motivation. So, what problems were needing to be solved, right? What led us down this path? And when, even actually before ACCURE was founded, we knew several operational requirements that we knew that we would need to develop our solution around. So we knew on the one hand that we wanted to stay in Python, mostly because this aligned with our developers' skill sets. And not only that, but some of the people on our team had worked with other tools in the past, notably Spark, and really had they weren't so happy with it. Let's put it that way. And that's not just Spark itself, but also PySpark specifically. We were not so interested in because of how it flips between Python and the JVM. We also knew, and related to PySpark, we also knew that we wanted to go beyond simple black box type, or rather, we noted that we needed to go beyond simple MapReduce type functions. And we really needed to be able to scale any generic black box type thing in a lot of different environments, or rather contexts. We also knew that we wanted to have a shared development experience across all of our development environments, everything from testing to production to staging. We want these to be, we want the code that a developer writes and tests in Sandbox to basically be the same code that ends up, traveling all the way up to production, of course, once it passes all the tests and these types of things. We really wanted to avoid a situation where something has to be written specifically for production, but then a developer can't run that same thing locally without some very complex setup. So yeah, a shared experience there. We also knew that we wanted to do all kinds of parallel processing, both simple batch processing as well as like shared parallel processing. And we also wanted to promote self-service for our data engineers. And by this, I mean our data engineers, people who really focus on battery algorithms. They know batteries, they're pretty good at Python with Numpy, with Pandas, but they might not be the best with distributed computing, and they almost certainly aren't going to know things like cloud computing or Kubernetes. And instead of forcing everyone to become a generalist, we wanted to use a service or a tool that allows these data engineers to service themselves as much as possible without having to get into all that depth. We also had several.
Sorry, if I can just stop you there really quickly. As someone who has
Sure.
a background in education and looking at things like, that are as challenging as Kubernetes, when you're approaching a group of engineers and you need to get them onboarded and you need to understand, what they know, what they don't know, what they've learned, what they need to unlearn, how do you sort of develop if we want to call it an internal curriculum to make that happen?
That's a hard one, honestly, because everyone's coming in with their own goals, with what they're wanting to learn. And to be honest, I would say as much as possible, I've found a lot of success trying to make the tool match the developer, right? So that's actually a topic I'm going to talk about in this presentation today, where we took Dask, we took Argo, we kind of added a ACCURE specific layer on top of that, and then basically accomplished this task right here. Sorry, whoops. This like shared development experience.
Mm-hmm.
And then basically, allowing the developer to work in the thing that they know best, which is in this case, Python, Pandas, not having to think about all these other topics. And we just say, hey, make me a function, throw a decorator on that. You don't have to know what that decorator is doing behind the hood, but as long as you have that decorator, you're scalable. And then we found a lot of success with that. We have people who come in with very minimal experience, and they can run very large pipelines fairly easily. So hopefully that answers your question.
No, that's good. And the thing is, I don't think there's a single answer to that question. Just curious as to what your approach was, and particularly having been in academia as well. Anyway, crack on.
Sure. Okay, so infrastructural and security requirements. I think in the interest of time, I may try to go through these a little bit faster, but basically we knew that we wanted to have ultra low latency parallelization. We're going to have hundreds of thousands of batteries to monitor, and each battery has dozens of individual cells, maybe even hundreds of cells, which are each producing their own time series data, and they all need to be analyzed. And so if we have any sort of latency in our parallelization infrastructure at all, those like seconds that it takes to spin up a Kubernetes pod are going to be killer. So we knew we needed to avoid that. We also wanted to have a multi-tenant environment, because we were going to have multiple customers. And when I say customers here, I mean, the big OEM battery providers, not mom and pop who might have a battery in their garage, but rather, the company that mom and pop bought their battery from, right? And so we're going to have a few very big profile customers. We want to make sure that they don't have any chance of conflicting each other, or rather, are affecting each other. So, they should be as much as possible completely isolated, hence multi-tenancy. And if we want cost efficient computations, of course, automation in our deployments, version controlling, high data throughput, especially in this case, because we have a lot of time series data that needs to be basically reanalyzed every day when new data comes in. And then, other typical things that you would expect, secure access, dependable scheduling, logging, and archiving. So you might ask yourself, why not just use a service for our pipeline scaling? And actually, this was the first thing that we thought to do ourselves. So we looked at things like Apache Airflow and services that also provide Apache Airflow. And we weren't super happy with the learning curve there. And note that this was also before Airflow 2.0, which means it also didn't have the best Kubernetes support. And if we want to have Apache Airflow, we still need to maintain our own Kubernetes cluster. So it's not like we even avoid that complexity. We would still need to do that. There's also a nice service called Prefect, which actually for quite a while we were really happy with. It was the first one we were working with, rather the first one that we had signed on with. But at the beginning, they were kind of also an early stage startup that were obviously going through their own growing pains. And that ended up affecting us, right? And note that this was in early January, so that probably has changed in this time. But nevertheless, we had already decided to move on. And more importantly, they actually changed their cost model, which makes a lot of sense probably for a lot of customers, but for us specifically, it drastically changed our price point. So it no longer was an economic choice for us. And then we also tried some AWS specific tools like Batch and Glue, but we found these to be not so flexible. And if we could, we prefer to stay cloud agnostic. So in the end, there's only one option, and that's to Phi.A. Do it yourself. All right, so let's get into Kubernetes, Argo, and Dask, and maybe even hopefully have a little bit of fun. So these are the requirements that I just listed that we knew that we needed. And of course, we know that we want to go Kubernetes because yay, Kubernetes. And with that, we directly get multi-tenancy and everything else that comes along with Kubernetes, right? So we start with that. Actually, we're using AWS EKS here, but presumably you'd be able to use any Kubernetes cluster to do the same thing. We then slapped a K8's autoscaler in there, and that's what gives us our cost-effective scaling, right? So whenever we add some pods, the scaler scales the cluster up and down, and that works beautifully. So not much to think about there. We then used Argo Workflows, which let's have a quick aside about Argo Workflows. So Argo Workflows, for those of you who aren't aware, Bart, you mentioned that actually it's been talked about several times already in the docs community, but nevertheless, just a quick overview. Here's an excerpt directly from the Argo homepage. And in short, Argo Workflows is a Kubernetes-native workflow engine, right? Where you define each of your individual nodes. Here's an example of a DAG over here. You define each of your individual nodes, these little checkboxes, as containers, and then you string those containers in a directed acyclic graph, which you can see here. And I have shamelessly stolen this image from ArgoCon because I liked it quite a bit. Here's a workflow that teaches you how to make a cake. And you can imagine that each of these are, maybe this one's written in Python, this one's written in Go, this one's written in something else. You can really do a lot of things with Argo Workflows. It's great. And plus it's Kubernetes native. So everything that is nice about Kubernetes is also nice about Argo Workflows. And of course, you can pass information in between tasks and, as you might expect from a workflow engine. Okay, so back to the stack. So once we've added Argo Workflows, we get some black box genericness. Like I just mentioned, you can put any node, any image inside of any one of these nodes. We also get dependable scheduling, which is super nice. But Argo Workflows by itself does not solve our requirements, mostly because spinning up pods always takes some seconds, which maybe for you is going to be fine, but for us, spinning up 100,000 pods for one pipeline is going to take hours, and that's just not something that we can do. So so that one is actually kind of broken if we only rely on Argo Workflows. Also, self-service and the shared development experience are both broken. Because a normal developer, someone who doesn't know Kubernetes and doesn't know cloud, would have to learn, kubectl and these types of things in order to interact with Argo. So we wanted to avoid that. I'll come back to those broken points in a bit. But we also use Prometheus and ELK for our logging. Our ELK sits outside of our Kubernetes cluster because we found that to be a bit more stable. And also, here we just use the open stack service from AWS as opposed to managing it ourselves. So it's also easier. We have PostgreSQL, which then will archive all of our Argo workflows, so we know what ran when, how long did it take, we can crawl through histories. It's a really nice connection there. And of course, Postgres can also be our data, or rather can provide some of our data, but not at the high throughput that we're thinking about here. Because again, we can potentially have thousands of workers all working at the same time, and you can't effectively have thousands of workers all talking to the same PostgreSQL, pushing and pulling data all at once. So, we add S3 in there with a data lake type approach, and that gives us our data throughputness. And in order to make this all version controlled, of course, in infrastructure as code is your friend, we chose to use Pulumi for that because it can manage all of these things all at once. And we develop everything in GitLab, right? I think I mentioned that one previously. And then finally, sitting on top of all of these individual tools is Dask. So here's another aside about Dask. So many of you are probably new to Dask. So what is Dask, right? So Dask is it's a high throughput, or rather it's used for high throughput data pipelines in Python, right? It's a parallelization engine in Python, which has been around for quite a while. And it's quite nice that it splits the concept of pipelining into data collections, a task graph, and schedulers, right? And basically you can mix and match these things together. And in fact, you really only have to think about the collections and maybe the scheduler as well, but Dask always manages the task graph on your behalf. And so what's nice about that is you can use Dask collections like Dask arrays and Dask data frames, which are super similar to Numpy and Pandas respectively. Or you can use the futures interface for kind of normal batch processing type workloads. And you can build up a task graph basically in the same way that you would program any other Python script. So it almost looks indistinguishable. And Dask will put that into a task graph for you, and then it'll run that task graph on whatever scheduler is available, be it a single machine that runs, single threaded, or multi-processed machine, or even a distributed setting, like a Kubernetes cluster where you have multiple pods, which are all individual workers. So Dask can span all of these different domains. And what's nice about that is the developers on our team only have to think about the collections layer, right? So it's as close to pure data analytics Python that you can get, and we only have to think about the scheduler side of things, more or less on the infrastructure side. And Dask spans that gap for us. And Dask is really nice because it's useful also for any kind of parallelized workload. So embarrassingly parallel, totally fine. MapReduce type workloads similar to Hadoop and Spark, also possible. And really any other full task scheduling thing you can imagine, be it messy or otherwise, you can also do quite easily with Dask. So Dask comes out of the box with all these nice features. It's super easy to use, especially for people who are coming from, like the data side of Python. I think they would be very familiar with the Dask interface. And if you do have trouble with Dask, there's also, Dask has been around long enough that it has a lot of services available. You can get Dask as a service from people like Coiled, for one, is one that ACCURE uses. And there's also Saturn Cloud, and maybe even also a few others. So if you need help with Dask, you can also find it. As mentioned, ACCURE did have to implement some of our own things on top of Dask to really fit it to our particular use case. So things like work avoidance and task artifacting and logging we had to do. Those things are kind of out of the scope of the talk today, so I'll skip over them for now. Okay, back to the stack. So once we've added Dask, We then have our batch and shared parallel processing is checked. Our black box generic function is double checked here because we both have it checked, in my opinion, from the Argo Workflows perspective, where we can string together any number of like Kubernetes pods or containers that we might want to. But even across many pods, we can scale generic Python functions as well. So we have, like, in my opinion, very, very strong genericness here, and also very, very strong scalability. And Dask also gives us our ultra low latency, which ACCURE knows that we're going to need quite a bit. We are still missing our self-service, which we get from these Dask as a service companies, like I mentioned. Like I said, we use Coiled. And in order to finally make this shared development experience, so that the developers can really just think about one collections layer, we have our ACCURE utilities. And with that, all of our requirements are satisfied, and we can start building out our data pipelines. So that is our stack that we use. All right. So someone might ask, how can we combine Dask and Argo workflows? So I'll walk through this briefly at from a high level. So Argo defines custom resource definitions, of course, and it defines, among other things, cluster workflow templates and workflow templates, where cluster workflow templates, workflow templates will define a DAG, something like, okay, it's too far away, but you remember that DAG that I showed previously. This one can also be considered a very simple DAG. A workflow template will define a DAG, and a cluster workflow template does it at the cluster level, whereas a workflow template does it within a namespace. So the idea here is to make a standard Dask scaling workflow template and to put that at the cluster level and basically make that as abstract as possible, and something that's applicable to any pipeline that one could imagine writing in Dask, right? So the idea here is we have a cluster workflow template, and as long as we specify an image repository that we want to use, where there's an image in there that has a Dask pipeline, and we specify things like pod resources and pipeline settings, then this becomes something super general. And it's also fairly simple as well. I'll go through it in more detail later on, but basically the only thing that's happening in here is, the workflow template would first initialize the workflow that's going to, of course, get computed. It will then build out a Dask scheduler, where the Dask scheduler is, of course, doing the networking, and it's sending tasks around between the workers, and it's talking to the client over here to understand like what tasks need to be done. It also will do things like serve a dashboard that you can go to watch your pipelines, and a few other functionalities as well. So you build out your Dask scheduler. You then have to pass the Dask scheduler's IP address to the primary pipeline. This is just a container which runs the Python script, which knows to look out for this Dask scheduler and to start submitting jobs to it. And it also has to pass the IP address to Dask workers. And the Dask workers would come in as a deployment, and it would spin up however many number of workers that you want. And those workers will be alive as long as the pipeline is getting computed. And they'll just be performing tasks that the pipeline needs to be performed. And then at the end of the pipeline, or rather at the end of the workflow, once the pipeline has finished, there's a teardown process, which makes sure to clean up whatever workers may still be online, and other things that were created along the way. And so that is our standard scaler, and we can tailor that to a specific pipeline. So for example, we want to compute, or rather we want to do the ELT pipeline for customer ABC, for instance. This would be a specific pipeline configuration around the general one. And here we just need to specify maybe which tag we're interested in, so we know exactly which image is being scaled out here. We want to say how many workers we should use, and whatever special pipeline arguments we might want to use. And as long as we specify those, they can be passed into here, and then everything is working well. And as mentioned, each of these nodes in the Argo workflows are containers, at least these orange ones are. And in this case, actually, these are all just a container which is built from, these are all the same, rather a container which is built from the same image, right? And this is just a simple Python 388 buster image with Dask and distributed and whatever other Python packages you need, cooked into the image. And then doing things like activating environments and doing whatever else you might imagine needing to do in your Docker image for your particular pipeline. But nevertheless, it's just an image that has the Dask scheduler, Dask worker, and the specific pipeline you want to run available on the path so that they can be accessed from Argo workflows. All right. Okay. So then I want to talk a little bit about today's demo. So today's, and actually, in fact, I realized that my slides are out of order. So this slide was supposed to come after this slide. So you can just imagine that happened.
You are forgiven. Not a problem.
Thank you. Thank you. So yeah, today's example is going to be very simple. Actually, it's just going to scale out a really basic batch processing workload, and in fact, kind of one that doesn't really make sense to do because of how simple it is, but nevertheless, it shows off some of the core features that I'm trying to showcase here. And given my personal history in renewable energy simulation, specifically in Europe, I thought it would be fun to look at time series weather data in Spain. And specifically, what we're going to do is look at 5 different cities in Spain: Madrid, Valencia, Barcelona, Sevilla, and Bilbao. I don't think I ever pronounced that one right.
That's okay. Don't worry. Most people don't. But yeah, Bilbao. That's where I am. That's good. That's very, very good.
Yeah,
it's nice to be included.
There you go. All right. So, and of course, I want to ask the age-old question: which is the windiest city? We all know Spain is a windy place, but which is the windiest? So, what we will do today is, I have an image, and in that image is some simple weather data, time series weather data, and I've written a script here, or rather a function in Python, which will look to that weather data. You just have to specify which city you're interested in. It will look into that weather data. It will look into that weather data, and at a specific timestamp, it will find which of those cities is the windiest. And then it's going to do that one by one for each city, for all timestamps, each as independent tasks. So there you see, it's actually, of course, there's way more efficient ways to do this. But each of these independent tasks will all happen on the Dask workers. And then that will get concatenated back into the pipeline worker, where we'll receive a count of how often each city was the windiest, and then we'll get a report for that at the very end. So that's our pipeline. Super duper simple. And more slides out of order. Super sorry for that. You can find this code if you're interested in. You can find it here. And you'll notice that my name is not here. That's actually because this demo was created with the help of the PipeKit team for another talk that we gave together. So shout out to the PipeKit team. That's actually another startup that ACCURE is working with. They've helped us install Argo workflows and do some other troubleshooting. You can find them here. But nevertheless, you can see our code here, github.com/pipekit/ArgoCon-demos. And yeah, so like I mentioned, this is going to contain our Dask pipeline, and helping you get set up in Argo, and also installing everything, and also showing the Argo workflow templates that we'll use. Okay, so one more example of things out of order. All right, so the demo stack that we'll use today, comparable to the full stack that we use at ACCURE, is of course going to be much simpler. So what we are going to do is just use Kubernetes, Argo workflows, and then just the Dask pipeline on top of that, and that checks most of the boxes for these requirements that I mentioned before, but of course not all of them. And I think that that's okay. For a simple demo, should be fine. All right. I also want to talk a little bit about what will happen inside of the Kubernetes cluster. So we have a fairly simple setup where we have the Argo server is installed in the default namespace. Next to that is also the Argo workflow controller. We have there's an Argo controller config map that's basically used to control how Argo behaves. We then have this cluster workflow template, this standard one that I mentioned over here. This one in blue, the generic one. So that will happen also in the standard namespace, or rather the default namespace. And, or rather, excuse me, it's actually at the cluster level, so it's not in any namespace. And we have some reusable cluster roles that allow actions to happen inside of specific namespaces. And then within a customer-specific namespace, we have a workflow template which will scale out the example pipeline that I just described by using the standard scaler. And we have a cron workflow template which will put that on a schedule so that it runs, for example, every Thursday at 2 p.m. And other customer-specific configurations, such as IAM credentials and API secrets. These types of things would also be in here as well. We will use a cluster-wide Argo Workflows installation. There's several different ways to install Argo, so we will use cluster-wide because that makes things easier. And like I mentioned, we will have customer-specific namespaces. In fact, we will have the a very interestingly named customer today. So very, very creative. And with that, let's go live. So here we have my code. And here you see me doing some testing, making sure things are working. So is this large enough, Bart? Can you let me know? I can go a bit bigger if needed.
If you can go a little bit bigger, that'd be helpful. Yeah.
Sure.
A little bit.
One more. There we go.
Yeah, it should be good. Yeah.
Perfect. All right. So so this is actually the code that you will find at the Git repository that I mentioned previously. I imagine if people are watching this later, they can just rewind and get that link. Or maybe Bart, we can share it afterwards, whichever makes the most sense. But anyhow, so you see in here the Argo Workflows installation. And this is a very basic installation. It's only lightly adapted from the quick start installation from Argo Workflows themselves. I think I've added in some specific things here for creating a namespace. Actually, I think you see that at the top. Yeah. So creating a namespace and a few other things that are specific to this demo. But for the most part, it's just a basic Argo Workflows installation. So I won't go through that in detail. But if you were doing this for yourself, you should actually be able to just kubectl apply this. I need to move my camera a bit. There we go. You should just be able to kubectl apply this. And actually, I'm cheating because you'll notice, already applied. But you'll notice that there's not so much going on. Get pods. So it's an Argo server and an Argo workflow controller. And normally these will come online in like a minute or two. So they're quite fast. It's actually quite pleasant. Right, so let's talk about this standard Dask scaler template. So again, I think in the interest in time, or rather in the interest of time to leave questions or leave room for questions later on, I won't go through this in explicit detail. I'm happy to answer questions about it later on if someone would like. But this is a Argo Workflows template YAML file, and you'll notice here that it's just YAML. It's actually quite similar to other Kubernetes resources. You have like metadata and spec and these types of things. And it does come in as a custom resource definition. So that's where we get kind cluster workflow template. And the template itself is actually, you define some number of templates, individual actions that need to happen within this workflow. and then you give it an entry point, which in this case is just main. And the templates themselves can, of course, accept some parameters, some of those parameters having defaults, others requiring, other ones being required. And then, a step can itself have several substeps, right? So here we are generating a Dask scheduler, like I mentioned, passing in the inputs from above, and and then after that, we would scale out our workflow. And here you see we pass on the IP address. So that's actually a super, super simple thing to do. Really nice with Argo workflows, in my opinion. And then inside the scaling, I just want to show off this real quick. Inside of the scaling template, we use the template called Dask Scaler, which is here. And this is another template which has these parameters which must come in, and we then create our primary pipeline, making sure to pass on the IP address and also our Dask deployment workers. And the primary pipeline is here, and this is a template which is actually just a container. So it's going to so this is where real computation is going to start happening. It's going to be a container. It's going to run this image that comes in as an argument, and it's basically just running a Python script. So nothing magical is happening in there. And the Dask worker scaler, where did I put this one here? This one is actually creating a resource, and you see here that it's creating a deployment, and that is just a normal Kubernetes deployment definition with parameterization. So, super intuitive to use if you have a background with Kubernetes, and you can get running with it right away. And then there's a few other, let me clean this up. There's a few other templates in here to do some cleanup afterwards, as I mentioned. Okay, that's it for the standard scaler. Let's talk a little bit about the specific workflow template for this, for this pipeline that I want to scale out. So here is a workflow template, which basically only has one step in it, and that's just a wrapping of the standard scaler. So this one here. So it just basically references that scaler, passes in some arguments here, and that's it. Doesn't need to do anything else. Quite simple. And so it defines some input arguments that we know, we always want to be true for this particular pipeline. It should always come from this image, for example, and it should always find the Python script that we want to run inside of this folder within the image. And we leave a few other arguments, like the number of workers and other arguments. We still allow those to come in at runtime, so that is fine. And there's another nice thing. We get some semaphore synchronization. So basically, we can say, hey, this pipeline can only run once in parallel, and that can help us from not overriding our database, or if this was an ETL pipeline, and making sure that it doesn't overwhelm like a customer's API or something like that. And then if we want to schedule this, we just have to create this cron workflow template, or rather cron workflow, where we just reference the Windy City template, this one up here. And we just say, yeah, please run for us. I think this is every Sunday at midnight, 13 minutes, if I haven't forgotten my cron notation, or every Monday, maybe. I always have to Google it. So anywho, so that is Argo. Let's talk a little bit about the Dask pipeline itself. So that here, now we're in Python territory. Quick left turn. So here we are with Python, and you see that we're importing Pandas, we're importing Numpy, and distributed, which comes from Dask themselves, just to give ourselves the client. And that is it. So there's actually nothing else that we need to make this run on the Python side. And here is our function for getting the windiest city. Like I said, it just takes in a date, It's then going to loop through all of our cities. It's going to, read a Parquet file, extract the date at that time step, and it's just going to say like, hey, the windiest city is X city at this time step. So, again, nothing super crazy happening there. And very, very inefficient. So like, don't make your Dask pipelines like this, right? There are much better ways to do this if you're trying to do exactly this, this task. But nevertheless, the important thing to mention here is that this is a completely, like, you could put anything in here. So this is just a Python script, right? There's no limitation to what could happen inside of this function, so long as you don't overwhelm the memory constraints of the worker that's hosting it. Yeah, and then our pipeline is basically going to, I'm not going to go through it in detail. Again, happy to answer questions later on if someone does have specific questions. But basically, we just have to run our get windy city function. We just have to submit it to our Dask client. And we do that one time for each timestamp. And then we just gather all those things, and Dask takes care of all the networking behind us or behind the scenes for that. And this is something that I could run this directly right now on my computer without thinking about Kubernetes clusters or parallelization or anything like that. I could run it completely in Serial. I could get into a normal debugger completely in Python the whole way, even down into the tasks. So it's really developer friendly, I would say. And then when I do want to scale it out, Dask handles that for me. And then here's a quick entry point, which allows me to execute this from the command line. So this is where my, if I come back over here to my primary pipeline in the Argo workflow, you see here that, this is where it's just running my Python script right there. So it's just coming in to here, and then that's where we get the connection into Python. And with that, that is it. So yeah, I think now is a good time to put my money where my mouth is and show you it working. So let's make some space. And all right, so I'm moving my camera. Okay, so oops, excuse me. And it's not what I would expect. Okay, anywho, so I should now be able to, see kubectl get pods -n customer. So customer is my namespace that I'm using, as I mentioned, and there should be nothing in there. Nice. And also Argo, sorry, not get list. Yeah, so we have no workflows going. Okay, so if I wanted to submit this pipeline, it's actually quite simple. Oh, actually, I totally forgot. So I've installed Argo Workflows, but I haven't added these templates. So let me actually do that real quick. So I will do just apply them real quick. kubectl apply -f Dask standard. So I'll just apply the standard workflow templates and also the customer specific workflow templates. And whenever you want to do it, nice. Okay, so now we should be able to see, let's say, customer get workflow temple. I think it's that. Maybe there's an M in there. Yes. Yeah, okay, so you can see that I now have my workflow template inside of the Windy City, or rather I have the Windy City template inside of my customer namespace. And I can also see what is currently scheduled, and you can see that my Windy City template is scheduled to run on that cron schedule that I mentioned previously. And the next run will be in 5 days. So some nice access to the current state there. And if I want to run that, again, making a little bit of room, I would just need to say, let's say Argo, actually I'm just going to cheat a bit. No, so Argo -n customer submit. There we go. Okay, So the notation here is I want to submit inside of the customer namespace this template, and I want to, override these arguments. I don't have to. I just, can if I want to. And as soon as I run that, let me put you up there. Can I squeeze in another terminal? Let's see. I think I can. Okay, so you see that the Dask scheduler has already come online. It is it's a daemon template, so because of that, it stays running the whole time, whereas the deployment workers just makes the deployment, so that's why it has the check mark there. And if I want to check out what's going on inside of that, I can do kubectl. Actually, I need to get this pod. So I mentioned that Dask has a dashboard, which you can check out, customer, and let's do port forward and paste that pod. And specifically, I want to forward the port 8787 because that's the port that Dask uses for its dashboard. And hopefully, if I haven't missed it, 787. Okay, cool. We are in business. You see that the pipeline is running, and it's actually still adding these tasks. So I didn't actually describe this notation that I was using over here, which of course you can't see anymore. But you'll notice that I said time steps equals to 10,000. That means I'm submitting 10,000 individual jobs. So that's why this number here is still climbing. I'm sorry if you can't see this. I actually can't make this, or maybe I can actually. And then if I refresh, and once again, Bart, you can let me know if this is something visible or not.
No, I can see it pretty well, yeah.
If it wants to come back, sometimes port forward struggles. Stop. Oh no, tragedy. So, broken pipe. Sorry, technical difficulties.
It's all good.
All right, you are not doing your thing, so let's do one more time. Okay, now we have a Dask dashboard again.
Woohoo! Looks good.
Yeah, thank you. So you see that it's scaling out here, and we have, you'll notice, I didn't show this before, and actually I'm sad that I didn't. But when we started this, we should have seen that there were kubectl. There should have been only one node, which is online. Get nodes, and now we should have more than one. If kubectl wants to, so this looks like this one is finishing. That's nice. Okay. You are struggling. Just quick internet check. Bart, are you hearing me?
Yeah, I can hear you, but your screen, your Zoom screen, it was frozen, but now it's not.
Okay, and also my internet is telling me that it's unstable, so that's probably what was just happening.
That's okay. Yeah.
All right, well, you know what? I think you can take my word for it. Basically, what's really nice about this setup is when the pipeline started, there was only one node online, but when we have, once the pipeline was running, yeah, you'll notice here that we have more nodes came online, and you'll see here that 3 of those nodes are much younger than those 2 of those nodes, which were online before. And that's quite nice because, the pipeline, the whole cluster scales up as the pipeline needs. So that's what I was trying to showcase there. But nevertheless, you get a dashboard, you get scaling, it's all well and good. So let me then come back to our presentation. And so that's it for the demo, short and sweet. I could go into more detail again if someone was interested, but I think that's enough for the time being. So let's just have some closing remarks. So the question, of course, is when would you want to use Argo Workflows plus Dask, and when would you not want to? So Personally, I've found that this tends to work really well, obviously, when you're working in a Python heavy team, and specifically when you're wanting to deal with scheduled workflows, right? So when you have scheduled automated workflows written in Python that need to scale out, maybe they use Dask, or maybe not, maybe use like OpenMPI or something like that. Also fine. Then I find that like the Argo plus Dask combination is a really good one, and we're quite happy with it. But for the periods where developers are in the loop, like we have some dev who's testing out a new feature or a new algorithm, then these like Dask as a service tools, such as, like I mentioned before, Coiled or Saturn Cloud, these tend to fit really well because they're the developers can actually operate completely outside of the Kubernetes space, and they just say they say, hey, Coiled, give me a cluster. I want 100 workers inside of it, and that might be a little bit more expensive than it would be in the Kubernetes setup, but it also nevertheless works fine. It's also important to mention that Dask is not a silver bullet. We have experienced some instabilities, especially for long-running pipelines. So we found that pipelines that take hours are generally fine, whereas pipelines that take days can sometimes have issues. You also can do batch processing like I showed today with Dask, but it's not, to be totally honest, it's not really the main focus of Dask. Dask really focuses on the shared parallel processing type use cases, with Dask data frames and Dask arrays. And, also it's important to mention that Dask is an active project, so it's also evolving itself. And I also wanted to mention that there are several Dask alternatives that you could consider using if you're interested in this, but if Dask isn't the right fit. So one example would be Cooler, which kind of allows you to develop Argo workflows, but to do so directly in Python. This wasn't the right choice for us because of this latency issue, but nevertheless, might be the right choice for someone else. And there's also a package called Ray, which is quite similar to Dask in many regards, also allowing for low-level parallelization in Python. I don't have specific or significant personal experience with it myself, but I've heard that it's also more stable than Dask, but maybe less featured. So a bit of a trade-off there. And with that, we are done. Hopefully, there's enough questions in the time in the end for questions.
I'm sure we're good. Yeah, but I think also you did address it because you were talking a lot about the positive sides, the benefits that Dask has provided in your particular case. Mm-hmm. But as you said in the very beginning, you try to match the tool to the developer, not the other way around. So being sensitive to that based on people's level of experience and what they do well, some things are going to work better than others. When we're talking about, as you've seen sort of this progress over time, where we're talking about infrastructure and looking at Kubernetes, one of the fundamental questions that comes up in our community is how Kubernetes was not originally designed for data in mind, which is why our community exists, stateful workloads, et cetera. What do you think are the biggest challenges right now that are preventing organizations such as, ACCURE, where you're working, end users, from adopting this strategy of running data on Kubernetes, perhaps in the case of Argo Workflows?
Yeah, well, it's very new. And, I would be definitely lying if I was saying that it was like all rainbows and unicorns using this approach on our side. We have had our fair share of headaches with it, and it's a very manual solution, right? So it's like, it's definitely requiring a lot of Kubernetes knowledge, a lot of Dask knowledge, a lot of distributed computing knowledge, and cloud knowledge, honestly, to pull it all together. And that might not be a setup that everyone has, and it's like not just that, but also, as I mentioned, Dask wasn't originally intended for this purpose. Yeah, it works well for this purpose.
Shoehorned in, we can say. Yeah.
Exactly. So, some of these other tools like Ray might actually even be a better fit there. Like I said, I haven't done that personally myself yet. Mm-hmm. But because of that, I could imagine that being a bit of a liability, because it's not a proven technology like Spark or Hadoop or something like that. But I do find it to be quite an effective one. Yep. So, I would say that to answer your question specifically, in my opinion, one of the main things that's like holding people back in this regard is probably just breadth of experience, because like all of these things are possible when you have a foot in all of these different buckets. But when you only know Kubernetes, or you only know Python, or you only know X tool, you might not necessarily think to put them together.
Got it. No, that's a very, very good point. Like the logic might not necessarily be there. And going back to what you mentioned previously, that's a really good point that you mentioned that hasn't necessarily been addressed in some of our live streams, although I'm sure a lot of people would agree that looking for proven technologies in an area that's so innovative, there's going to be scarcity. Like some of this stuff just hasn't been tested well enough to go to an innovation manager or CTO and say, oh, don't worry, this is a track record of 5 years, or in the case of, a Spark and Hadoop, we're talking now beyond 10, or getting close to 10 years. So that level of being battle tested, I think is definitely going to be providing some doubts there. But once again, that's why we have the community to get practitioners together to be talking about this. In terms of the benefits that you've seen provided to your organization because of choosing this strategy, what would be some of the key things that you would say have stood out for you that could perhaps serve as an inspiration for other organizations that are considering taking that route?
So yeah, I mean, I would say the two biggest strengths that I would really like to highlight here are the genericness of this setup. So, I mentioned that before, but, just to mention it again, Argo Workflows already super generic because you can just string these containers together. And for people who prefer to stay in the Python world, you really can't get more generic than what Dask allows, at like a super low level. Dask really provides this high level interface that allows for a lot of things, right? And that includes ML type applications, ELT applications, or other things that need parallel processing. So like Dask really lets that happen. And the other real strength of this, in my opinion, is again, bringing the scalability to the developer who doesn't need to understand anything about Kubernetes and doesn't need to understand so much about like distributed computing and these types of things. And it really allows people to, I would say, specialize, which is very important in ACCURE's case.
That's a good point. And I like what you said there too, is that, and there's now going to be a documentary coming out about Kubernetes, and there's been plenty of conversations about this, about how maybe not everybody needs to know absolutely everything. So like you said, that importance of specialization. And to some people, a lot of this stuff can be in the background, behind the scenes, under the hood, et cetera. For those who need to know, they will know. And for others, it'll just be, something they won't necessarily be interacting with directly. So I think that's those are very, very good points. That being said, if people want to find out where you are, how can they find you? LinkedIn, Twitter, what's the best way to do it?
Good question. Actually, I meant to put that on my last slide. But why don't I, just for the sake of people who look at this later on, so I can go ahead and write them down. So back to my screen. So cool. Email s.ryberg@accure.net. LinkedIn is, I think, my full name, which is, I can't even spell my name. There we go.
Yeah, you're definitely the first person I've met named Severin, so easy to find in that sense.
Yeah, well, here's the twist. My real first name is actually, so my GitHub is going to be Severin.
Okay.
GitHub. And LinkedIn, in case you're interested, is going to be, here's the twist, David Severin Ryberg. So first name is actually David, but I go by my middle name, Severin.
Ah, okay.
Yeah.
But, so Severin is a last name or a first name?
Depends on who you talk to.
Okay. That's cool.
Yeah. But yep, that's where you can find me. And besides that, I am.
But
also...
if you want to share your screen so we can see that.
Oh, I am not sharing my screen.
Yeah. It's okay. We're having a nice chat. It's okay.
There we are.
Back to the beautiful coffee cup.
Lovely.
Okay, zoom in. Yeah, but anyway, folks will be able to see that just fine. So yeah, there you got the email, GitHub, LinkedIn as well. Also, in the DoK community in the Slack. So I'm sure for folks that are watching this, if you want to take the conversation a little bit further, feel free to jump in. As I've said, we've had other talks around this. We've never had a talk that's matched up with Dask, and taking a look at the way that you did. Also very nice to see from an end user perspective. That's really, really nice to see that too. Also seeing your background in looking at and renewable energies. That's probably a conversation we could take further. But really appreciate having you here. Last thing, can I ask you to stop sharing your screen so I can share mine really quickly?
Absolutely.
All righty, perfect. So, we have a tradition in our community that while our speaker is giving their talk, we have an amazing graphic recording artist who's behind the scenes, creating a depiction in real time of the things that are being mentioned. Unfortunately, we're not able to get conclusive evidence about the windiest city in Spain, so we'll leave that.
Oh, I forgot that part.
But I think I would put substantial money that it is Bilbao, because you can. Yeah, I like to go running, and you can run in with the wind blowing towards you on the way out and the wind blowing towards you on the way back. It's amazing here. So yeah, we have also, and when planes land in the airport here, that's always a bit of an interesting experience, because the airport is basically put in like a wind tunnel in a valley. So the wind comes in quite strong. But I would be curious to know how the other Spanish cities rank. So that's a conversation we can continue later on. But anyway, Severin, thank you very much for your time today. Extremely informative. We'll definitely want to have you back soon, so you can expect to hear from me. And wish you nothing but the best.
All right. Thank you so much.